Every sport has its signature move. In baseball, it's the grand slam home run. Basketball, the slam dunk. But in hockey, it's the slap shot. So my first problem is I can't get it off the ice. But anyway, you'll see.
I don't think Jay has any chance.
Do I have to be this far back?
Come on, Jay.
Okay, you guys ready?
Go easy.
Yeah? Okay. The best part is, he barely moves.
Jonas doesn't look impressed at all.
Gotta keep your eye on the puck. Come on. Okay, so among the 17 things that I'm probably doing wrong, what can I fix?
I mean, you can definitely have some more knee bend, and obviously in the second one there, you missed the puck, so keep your eye on the puck, and
yeah.
Keep your head down a little bit.
He's being kind. Keep the knees bent. As you'll see, there's a lot more to it than that. Check out how Jake does it.
So a good knee bend, eyes on the puck.
Yeah.
Nice.
Oh, nice stop, too.
The slap shot is really a collision between a puck, which is very small, and a player which is rotating. That motion is done in a very special way. There's a trick to it.
Slow motion will help us see it.
You wind up as far as you can, so as to gain as much momentum, as much speed as you can on the way down. Players will typically do almost like a 180-degree rotation or even a bit more.
Then you swing down as fast as you can.
So the faster he is, the more energy he will have, and the faster the slap shot will be.
Now here comes the trick. Don't just slap the puck.
When you have a small object at rest, zero velocity, being hit by a heavier object oncoming to it, there's a speed limit which is twice the velocity of the heavy object. Now, 100 miles per hour slap shot would be very difficult to achieve on a direct hit because your blade would have to go at least 50 miles per hour, and the spin would be enormous. So what happens in a real slap shot is that it will hit the ice before the puck to about maybe a foot. What it does is it coils or bends the shaft of the stick and accumulates energy into the stick.
Yeah, it just happens. I don't really think about it. It's maybe 5 inches, 3 inches. You definitely want to hit the ice first to get that whip of the stick.
The third and final stage is when that flexure of the stick transfers its energy to the puck.
Let me, this is when he's coming down? Okay, whoop, right there.
So the blade will come, touch the puck, and then push on it, sweep, and transfer the energy and give the speed to the puck. People talk a lot about the flex of the stick, the stiffness of the shaft. You hear a lot, oh, I want to shoot fast, so I need a stiff stick. Stiffer stick will give you more velocity. However, it simply means that you have a stronger player using that stick. Because if you can't bend that stick properly, you're not going to get the full velocity out of that.
Play that.
Cool. And typically, the middle of the shaft will have to bend by 10 to 15 centimeters. Good transfer of energy.
We're going to take a little detour now and learn more about the hockey stick. In the beginning, they were all wood, then aluminum, fiberglass. Now, it's all about composites. It's nicknamed the Wall, and the guy in charge of sticks at Bauer is looking at it.
To make a composite hockey stick, what you're taking is anywhere from 13 or 17 layers of carbon fiber or fiberglass, and you're compacting them together.
That's what gives them flex, which is what the stick is tested for here. They support the shaft at 2 points and apply a load at the end. In all, 19 points are checked. And there's this, the robot. 1,000 newtons of force equals 120 kilometers an hour. And a 400-gram stick bends 10 centimeters. Oh, look at this. This thing bends like a branch. That's amazing. Okay, let me try this one. This is a very tall stick. Okay. I can bend it, but just barely. It's an incredible difference. Tell me about these two sticks.
Well, this stick right here is a special stick we made for Hal Gill, a very tall player. It's a 122 flex stick, so it's a very, very stiff stick.
The stick I could bend was Phil Kessel's, an 80 flex.
What you're seeing today is more and more guys going to a lower flex, where they're actually allowing the stick to do more work for them, where it really allows you to load up the stick, put a lot of energy into the product, and have it release out later on.
Alexander Ovechkin uses an 82 flex. Fratton uses an 87. Gardner a fairly stiff 95 flex.
You know, make sure your stick is the right flex. I think some people, when they grow up, they have little kids aren't strong enough to use, you know, stiffer sticks.
But make no mistake about it, bending the stick properly can add 50 kilometers an hour to your shot.
And just try and lean into it and just have your head up and you're trying to see where the goalie's giving you and just try and pick the corner.
So you can actually pick the corner with a slap shot?
Yeah. I feel like I can.
I wish I could. Coming up, what does a slap shot look like from the goalie's point of view? Well, let's put it this way. What's faster, the arm or the leg? And how far would a slap shot travel if there were no boards to stop it? And later, what makes for the perfect wrist shot?
That change made a big difference, I believe, in the outcome on the target.
Why is ice slippery?
Canada should like that because they live with this stuff.
And what are the secrets of the Steven Stamkos workout? It's a heck of a ride, so stay with us. Jonas Gustafsson is a typical NHL goalie. He's over 6 feet tall and weighs about 200 pounds.
And if you look at equipment size for a goalie, you can cover something like 60% of the area of the net just by being there.
The slow motion will show us how a goalie protects the other 40%.
Are we up, Marty? And action!
A goalie is first alerted by two stimuli.
The fastest is the auditory stimuli. So the sound stimuli will travel to the brain in 140 milliseconds.
Visual stimuli take 40 to 60 milliseconds longer to be perceived. That's probably because the visual process is so complex. It takes the brain longer to compute. The goalie perceives the shot, but doesn't react right away.
There's always some time between that and him starting to move. 1.5 tenths of a second.
As Alain gets ready to test his reaction time, here's a quirky fact. Your reaction time is slightly faster when you inhale than when you exhale. That's probably due to an increase in oxygen to the brain.
The basic reflex, that is if you hear a loud noise and you jump, that time lapse is something that we're born with. And it varies a little bit from individual to individual, but it's not something you can improve.
At first, the guys take it easy.
That was good.
Alain made a lot of stops. But then they speed it up, and his reflexes are overwhelmed. Too much exhaling.
By the time you try to move your glove,
That's good.
it's behind you.
So what happens once the goalie perceives the shot and starts to move?
Action!
Many adopt a stance called the butterfly.
Cut!
So the butterfly style is where you put your pads horizontally and you cover the whole bottom of the net. The butterfly style is the result of the fact that legs will move slower and respond slower than the hands. Roughly speaking, you're looking at 2/10 of a second for the hand and double that for the leg. It leaves the upstairs vulnerable, but the gloves and the blocker are faster, so he's hoping that that's going to compensate.
However, sometimes not even the butterfly can stop a 90-mile-an-hour slap shot.
From the blue line, it will reach the net in less than half a second. Now remember that the goalie takes at least 2/10 of a second just to react. Half of the distance is already covered by the puck by that time.
The blue line is 60 feet away. So what happens from 30 feet?
Within that dead zone, if a goalie receives a full velocity slap shot, he simply doesn't have enough time to react. And that is simply due to the fact that there's a human limit to reaction times.
Slap shot or wrist shot, what would you rather face?
A quick wrist shot that's maybe not as quick, but the release is really quick, and it's tough to read where he's going to place the puck.
You can see why he says that when you watch Matt Fratton and Jake Gardner. It's my turn.
No laughing.
I think my wrist shot is better than my slap shot, but it's still no world beater.
Not bad.
I need some coaching.
You just kind of lean into it and let the stick do the work.
If only it was that easy.
Letting the stick do the work, okay? It's not doing anything.
You gotta talk to it.
The hockey gods are not amused. So what does go into a great wrist shot? I went to a lab in Montreal to find out.
8.9 centimeters.
The Ice Hockey Research Group
8.3 centimeters.
at McGill University
10 centimeters as well.
uses these measurements
7.4 centimeters.
and 48 markers all over the body
We'll get this on you here.
to get their heads around the wrist shot. 8 cameras around the room send out infrared light. The light strikes the markers and bounces back to the cameras. They each capture 240 images a second. They're sent to a computer, which turns them into a 3D animation.
Step over here and put the speeds on.
They use a polyethylene sheet as a stand-in for ice. 25 players laced up for the study. Some played varsity hockey, some were nowhere near it.
In this case, we did the studies like about 4 meters away from the net. And if you looked at the targets we had, it gave you about an error of plus or minus 1 degree. So, I mean, it's a really small target. If you put your thumb out, like that's your error that you have.
Players took 20 shots at each target.
The question is, how did you manipulate the stick and the puck to achieve getting to that target?
This study of motion is called kinematics. It produces animations in wireframe or something fleshier. Either way, it shows the difference between accurate and inaccurate shooters is quite jarring.
So applying it back with some animation makes it a lot easier to pinpoint the areas where visually it looks different, and then we look into the data to make sure things are different as well.
Difference number 1, the shoulder and wrist.
Inaccurate shooter would lock the wrist and do all the adjustment with the shoulder.
And the accurate shooter?
So the shoulder would be really stable, but a lot of variability from trial to trial at the wrist, since it's a lot easier to make last-minute adjustment with your last effector, which in this case would be the wrist.
I'm a good example of difference number 2, balance.
I missed that one.
One of the first things, it was quite evident that the poorer shooters, they can't stand up or their stability is compromised. So much so that it makes sense that they're not going to have much control of the upper body and hence the stick.
The accurate shooter uses his back leg for balance.
He's moving the center of mass really, really close to his front foot, knowing that the back foot is going to be moving backward a little bit to cancel out some of that energy that's being created, rotating the torso.
Difference 3, the swing. The inaccurate shooter swings in a short, straight line. The accurate shooter has a longer, curved swing.
As we can kind of see a check here.
That gives them a large window at which they could release the pucks. That enough change made a big difference, I believe, in the outcome on the target.
That wasn't on camera.
For the record, I did hit targets, just not consistently.
Something wrong with these pucks.